going to be talking about the quadratic formula and the discriminant. Again, something that you should have covered in Algebra 1, depending on what time of year it was and when you got to this, how much experience you'll have with this. But if you don't have much, that's okay. It's not an incredibly difficult thing. It's going to combine a lot of the things that we've already done, okay? So when we're dealing with quadratic formula and the discriminant, it's a quadratic equation. If you're going to solve it using quadratic formula, it needs to be in this form. What other method have we talked about where it had to be equal to 0 before you could start? X is a variable. What is the X method used to do? Factor the polynomial. So if we're going to factor, it had to be equal to 0. That's right. That's the right idea. Okay? So using the quadratic formula, it's got to be equal to 0, just like if you were going to try to factor it to solve it. So we get it set up just like we did when we were doing the factoring. But factoring doesn't always work. There are some quadratics that you do the X method, and there's nothing that multiplies to be 11 and adds to be 17. You know, maybe it's something like that where you tried that X method. It just doesn't work. There's no numbers that do that. And so quadratic formula gives us an option to be able to solve those equations even though they won't factor. So quadratic formula is what we're going to use here. And the A is the coefficient, the number that's in front of x squared. B is always the number that's in front of x. C is always the number on the end. We need it set equal to 0 to be able to do quadratic formula. So we have those things there. So with quadratic formula, you need to memorize this formula. Negative b plus or minus square root or radical, meaning they are the same thing. And then all of that is divided by 2a. Okay. Does that look familiar? You've seen that before? Exactly. Yeah, all too familiar with this thing. Okay, so memorizing this formula is important because when you go to take the ACT, they're not going to give you a formula. They may give you quadratics to solve. This is a great formula to memorize because you can use it for quadratics. It works every time. Factoring doesn't always work. Solving by square roots is not always an option. Complete the square wasn't super difficult, but it took a few steps, and we sometimes ended up with fractions in there, and it made it hard to do. So completing the square is really probably my last choice when it comes to solving quadratics. I'm usually a factor first if I can, square roots if I can, and then quadratic formula if neither of those work, or if I just can't find the numbers. Okay, so those are the things that's the kind of the protocol that I use. Now, memorizing this formula is not a hard thing. I'm not really great at memorizing information, so I have to find tricks and ways to do that. So the way that I memorize this is by singing it. So you guys are going to help me sing it today. I videoed first block singing it, so I'm on video you guys singing it, and Mr. Walls is going to judge it and put the best one on social media. So I expect you guys to be better, just because you're awake and well rested and ready to go. To sing this with me, you need to be familiar with the tune to "Row, Row, Row Your Boat." Row, 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 row your boat. That tune, that melody, is what we're going to play off of. And the lyrics are the formula. And the way it goes is x equals negative b plus or minus radical b squared minus 4ac divided by 2a. That's how we're going to sing it. I'm going to say square root. I'm going to say radical instead of square root. And we will sing it and we're going to practice it a few times, and then I'll break up the camera. Okay. So this is how it goes. X equals negative b plus or minus radical b squared minus 4ac divided by 2a. Get it? All right, well, let's sing it a couple of times, and you just kind of join in here. And the more that you participate and have a little bit of fun, loosen up, don't take yourself so seriously. Some of you are probably great singers, and we just don't know it yet. Some of you may not be as good as singers, so that's okay. This is not the voice for American Idol. It's math class. So just memorize the formula this way. Okay, so x equals negative b plus or minus radical b squared minus 4ac divided by 2a. Again, x equals negative b plus or minus radical b squared minus 4ac divided by 2a. I can't hear you. X equals negative b plus or minus radical b squared minus 4ac divided by 2a. Again, x equals negative b plus or minus radical b squared minus 4ac divided by 2a. Oh man, that was great. Good job. Give yourselves a hand. Wonderful. Auditions for chorus. I'll make sure I will share that video with Miss Gladys and Mr. Walters so that they can recruit some folks to do that. Okay, so memorizing that formula, that'll get stuck in your head. You'll have it memorized in a short amount of time. Inside of the quadratic formula is this thing called the discriminant. And the discriminant discriminates what kind of solutions you have. The discriminant is the b squared minus 4ac part, the stuff underneath the square root. That's what the discriminant is. If that number, when you work that part out, is less than 0, what kind of number is it? Negative. And when we have negative numbers under square roots, what does that turn into? Imaginary numbers. So that means that they're actually called what kind of numbers? Complex. So what that means is if you have a discriminant that's less than 0 or negative, that you're going to have two complex solutions. Okay. Based on what the value of b squared minus 4ac is, the discriminant, that tells you what kind of answers you're going to have. So if it's negative, we're going to have two complex solutions. If b squared minus 4ac is equal to 0, what's the square root of 0? 0, right? And if I add 0 to something, does it change it? If I subtract 0 from something, does it change it? No, so it gets the same number. So you're going to have one repeated solution. Okay. It's repeated because every quadratic equation has how many solutions? 2. Always 2 on quadratics. Maybe the same one twice. That's the case that happens when the discriminant is equal to 0. So what's the only other scenario? Greater than 0, which is what kind of number? Positive. So if it's positive, that automatically means we're going to have two real solutions. So real numbers. If it's positive and a square number, so if it is square, then there are two rational solutions. Okay. So what do I mean by if it's a square? What do you mean square number? Give me an example. 81 is a square number. Why? Because 9 times 9 is 81. What's another square number? 49. Because 7 times 7 is 49. Okay. So square numbers underneath the square root indicate that we're going to have rational solutions, which is a little more specific than real numbers, right? Complex numbers, i's, negatives under the square root. 0, we're only going to have one answer. It's going to be a repeated solution. And then a positive number, if it's a square number, we're going to have two rational solutions. If it's just any positive number, like 32 or something like that, then we're just going to have two real solutions. So what this does is it helps us know what to expect when we're looking at equations. So the idea here, as we finish today's lesson and go through all this stuff, is we want to first practice quadratic formula But then we want to be able to look at a problem and kind of decide what's the best course of action to solve it. What's the most efficient way to solve it? You guys know when you take into course and ACT, it's timed. And one of the big factors on ACT math is the time limit. You've got 60 problems in 60 minutes. You have 1 minute per problem. Hopefully you can get some of those problems done in less than a minute so that you can spend more minutes on the harder problems, right? So if you know the most efficient way to solve a problem, that's going to save you time and save you effort when it goes through this, because it may not be the only way to get to Jackson, to go straight to Selmer and go on Highway 45 north, right? That's one way to get to Jackson. Probably the most efficient way to get to Jackson from here, but is it the only way? No, you could go up 22, go to Lexington, get on I-40 and go across. Yeah, you could go to Enville and turn up Finger Road there and go that way. There are a lot of different ways. We want to be able to find the most efficient way to solve a quadratic. So we're going to work on that today too. So we're going to start out by just refreshing ourselves on quadratic formula and being able to solve with that way, because it's like this universal tool. It will work on every quadratic, but it still might not be the most efficient method to solve certain quadratics. So we're going to work on being able to do quadratic formula, and then we're going to look at some problems and decide what's the best way to solve those. Based on just looking at the equation and then maybe even looking at the discriminant to help us find that. So let's look at an example here. X squared plus 2x minus 63 is equal to 0. So we're going to practice using the quadratic formula first here. So is that one in the right order? Yes. Is it equal to 0? Yes. So it's ready to either factor or do quadratic formula. We're trying to practice quadratic formula, so we're going to use that method. So in my Algebra 1 classes, I generally make folks write this list, A, B, and C. It helps them kind of make sure they got the right number there. So what's A for this particular quadratic? Well, 1. B is 2, and C is negative 63. Be careful and keep your sign with you. Whatever sign is in front of that part, that's the sign that goes with it. And then instead of jumping straight into the quadratic formula, I'm going to do the discriminant part first. Okay, so I'm going to do the b squared minus 4ac part first. So b is 2 minus 4 times 1 times negative 63. And I'm going to work that part out. So that'll be 4 plus 4 times negative 4 times 1 is negative 4. Negative 4 times negative 63 would be a positive 252. And then when I add those together, I get 256. Does anybody know anything about the number 256 in terms of square roots? It's 16 squared. If you don't know that, that's okay. We got a calculator that can help us. We know that anytime I do that quadratic formula and I get that, or the discriminant, I'm going to check that number, 256. Take the square root of it. If I get a nice clean number back, I know I got a square number. And what does that mean about the solutions that I have? 2 rational solutions. So I'm going to write that out. 2 rational solutions. That's what it tells me. So then I can go over here and start my quadratic formula. So x equals negative b plus or minus radical. B squared minus 4ac, I already know the answer to that. It's 256. So that's what I'm going to put underneath the square root. And then 2 times a be 2 times 1. And then I'm going to simplify as much as I can. I know already that the square root of 256 is 16. So my next line is going to be negative 2 plus or minus 16 over 2 times 1 is 2. Right? Are these like terms up here in the top? Negative 2 and a 16. Can you put them together? Yeah, there's not a radical, there's not an I on that, so that means I can work this out. So I'm going to split it apart. Negative 2 plus 16 over 2, and then negative 2 minus 16 over 2. And simplify those things. So that'd be 14 over 2 is 7. Negative 18 over 2, negative 9. And those are my solutions to that quadratic. Here's something that'll help us later on when we start trying to decide what method to use. If the discriminant is a square number and you've got two rational solutions, that means the quadratic would have factored. We could have used the X method and factored it. That's something that could help us later on. So kind of maybe store that somewhere in your noggins, that's what can happen. Let's look at number 2. 6x squared minus 11x minus 5 is equal to 5. What do we need to do first? Get it equal to 0. So that would entail subtracting 5 from each side. And that's going to be 6x squared minus 11x minus 10. Do what now? List my A, B, and C. A, B, and C. What's A? B, negative 11, and C is negative 10. Okay. Do the discriminant. So negative 11 squared minus 4 times 6 times negative 10. That's going to be 121 plus 240, which is 361. That one I don't recognize as much because you get past the 15 or 16, I don't know too much. So I would just go to my calculator and I would just try the square root of 361. It happens to be a square number. I probably wouldn't have recognized that off the bat, but just because I don't have them memorized up that high. Okay, so I know that's going to be 19. So that's a square number. So we know that this one has two rational solutions. That also tells us that we probably could factor this quadratic. If we did X method on it, it would get us the same solutions. So just like when we were doing systems of equations and we did elimination and substitution and that RREF on the calculator, we always got the same answers. Quadratics are the same way. If you can factor it or do quadratic formula, they both should get the same two answers, no matter what, unless you're doing something wrong. Okay, so that tells us we should be able to factor it, but we're going to practice quadratic formula. So x equals negative b minus b squared minus 4ac divided by 2a. Okay, and then simplify positive 11 plus or minus 19. Is that what that was? Yeah, 19. Over 12. And then I'm going to split those two apart. 11 plus 19 over 12. 11 minus 19 over 12. It's going to be 30 over 12, which ends up being 5 over 2. And this is negative 8 over 12, which ends up being negative 2 over 3. Good job. Had you done factoring with the X method there, you would have gotten the same solutions out of that with roughly the same number of steps out of that. So not too bad. It's not, super strenuous. You have a formula. It has certain pieces in it. A is this, B is that, C is another number. Put them in the right spot and work it out. It's not exactly super daunting work here. Let's look at this one. Negative 2x squared, so throw a negative in there, plus 4x equals positive 2. So what should I do first? Okay, if I subtract 2, that'll get it equal to 0. What do I notice about that problem? They're all divisible by 2. Do I have to divide by 2? No. Would it make things easier if I do? Yeah. because it's going to make my numbers smaller, right? And anytime I can make the numbers smaller in the problem, that would be helpful. Yeah, it'd be an ideal situation to have smaller numbers, get the same answers. So I'm going to divide by -2, just to get rid of that negative in the front. So everybody gets divided by that -2, the entire problem. So that's going to give me x squared minus 2x plus 1 is equal to 0. And finally, I have this quadratic in the form to where I can do my quadratic formula, which means I can do the discriminant. So -2 squared minus 4 times 1 times 1. Right? So that would be 4 minus 4, which is 0. What does 0 tell us about our solutions? One repeated solution. Someone first block said, I wish all of them had a discriminant of 0, because it really makes this math super easy. Because then that ends up being 2 plus or minus 0 over 2. And what's 2 plus 0? 2 divided by 2 is 1. What's 2 minus 0? 2 divided by 2 is 1. We get that same answer twice. So it's a repeated solution out of that. So x equals 1 counts twice in this case. Okay. If you wanted to just write it once and then, we say it's repeated, that's fine. But I just wrote it twice because it's about the same amount of writing. Okay. All right. So a discriminant of 0, example of that. Look at number 4 here. 9x squared minus 1 is equal to 24. This one should look kind of familiar with some of the stuff that we did right before fall break. As we kind of start bridging this gap between quadratic formula and the other methods. We're going to practice quadratic formula on this, but when I see this problem, what's the only variable in there? The x squared part. So what would that make us think the easiest way or most efficient way of solving that would be? The square roots would be the most efficient way to solve that because it's only got an x squared in it. That would be how most efficiently to solve this problem. We can do it with quadratic formula. We're going to get the same answers. Okay. So if I do quadratic formula, I would subtract 24 to get 9x squared minus 25 is equal to 0, which when it's equal to 0, what does it look like now? A difference of squares. So we could actually do it with factoring and get the same answers as well through about the same amount of work, no matter what direction I go in. So we see with this one, we could do square roots, we could do quadratic formula, which is what we're about to do, or we could do factoring. All three of those methods should end up with the same answer. We're going to do quadratic formula here. So A, B, and C, I didn't write that on the last problem. We'll talk about it here because this one's a little different. What's A? 9. What's B? 0, because it's not there. There's no plain x. And then C is the -25. So when you do the discriminant, you got 0 squared minus 4 times A times C, which is -25. So that'd be 900, wouldn't it? 4 times 25 is 100 times 9 is 900. Is 900 a square number? Yeah, it is. It's 30 squared. So this is going to be 2 rational solutions. And x equals 0 plus or minus the square root of 900 divided by 2 times 9. So that'd be plus or minus 30 over 18. The square root of 900 is 30. And the 0 in the front just goes away because it doesn't do anything, right? So we need to split that apart into positive 30 over 18 and negative 30 over 18 and reduce those fractions. 6 goes into 30 5 times and into 18 3 times. And this would just be the negative of that. Positive 5/3, negative 5/3. If we had solved that by square roots, by adding 1 to each side, dividing by 9, and got x squared is equal to 25 over 9, and then took the square roots, what's the square root of 25? 5. What's the square root of 9? Same two answers, right? Okay. Notice that the square roots method was much more efficient. It was quicker, right? We didn't have to do all the discriminant and all that other mess out of that. So the idea here, we're making sure we know how to do quadratic formula, and I want you to realize it works every single time, but it's probably not the most efficient method every single time. Factoring is sometimes quicker. In this case, square roots was the quickest way to solve that problem. So I want you to kind of see that all of these methods interrelate, and some are better than others for different problems. And I want you to be able to recognize what's the most efficient method to get there. Let's look at number 5. 8x squared is equal to 10x. Pretty easy problem. If we're going to do any way of solving this one, can I do this one with square roots? This is yes. This is no. No, why not? What's the reason I can't? It's got an x, plain x in there. If it's got the plain x in it, you can't do square roots. The only time you can do square roots is if x squared is the only piece that's in there. Okay, so I can't do square roots with this one. So I need to either do factoring or quadratic formula. Obviously, we're trying to practice quadratic formula, so that's the method that I'm going to shoot at here. But since we're kind of reviewing those other things too, how could I factor that? No. 2x is the GCF. It'd be 4x minus 5. And we could solve it that way. Y'all remember factoring and solving that way. It's been a while, and a couple of weeks. But we could factor and solve it, and we get x equals 0 from the 2x, and then x equals 5 over 4 from the other factor. So we know what our answer should be when we do quadratic formula for this. So factoring is probably the most efficient way for this one. So that might be kind of a clue. Hey, this one didn't have a C value. So a lot of times when there's not a C value, but an A and B value, factoring might be the best way to go. But if we do quadratic formula, A is 8, B is -10, and C is 0, then we could do our discriminant, which would be 100, which is a square number, so it's 2 rationals. And then you could do x equals -b plus or minus divided by 2a. All right, so that'd be 10 plus or minus 10 over 16, right? And what's 10 plus 10? Over 16. So that would be 20 over 16 reduces to be 5 over 4. And then if I did 10 minus 10 over 16, that's going to be 0 over 16, which is 0. So same two answers that I would have gotten from factoring, I got with quadratic formula. So factoring definitely more efficient for this problem, but we still get the same solutions using quadratic formula. So we're trying to look at things with a more of an analytical eye about it and try to figure out what's the most efficient way to get there. A lot of times it's going to be the first method you see. Instead of sitting there studying on, I'm not sure which road to take. Well, whichever one you see first, take that road, and you usually you'll end up with an answer. Just understand there are certain times some methods don't work. All right. So let's look at this one. X squared minus 9 is equal to 4x. What do I need to do with this one? No matter what method I'm trying. Subtract the 4x. Get the x stuff on the same side. And that's going to give me x squared minus 4x minus 9. So if I were thinking about this in terms of picking a method to solve, I'm going to do quadratic formula on this one. But if I think about x method, I got to have things that multiply to be -9 and add to be -4. Are there any numbers that even do that? Think about things that multiply to be -9. -9 and 1, -3 and +3. Neither of those add to be a -4. So I know factoring doesn't even work here. So that's out. The only other options I have are complete the square. You hardly ever pick that option. Or quadratic formula. I'm going to do quadratic formula to solve this. So let's do the discriminant. So -4 squared minus 4 times A times C. It'll be 16 plus 36, which is 52. Is 52 a square number? That was small enough we probably should know that. No. So that means this is not going to be a rational solution. And what kind of solutions are we going to have? 2 real solutions. So if it's not a square number, that means you're going to have a square root left in it. Okay, so when we go to simplify this and work it out, we're going to have to simplify the square root of 52. So when I go to do my work, -b plus or minus the square root of 52 over 2 times 1, I need to break down the 52. 2 and 26, 2 and 13, so there's a pair of 2's. So that's going to be 4 plus or minus 2 square root of 13 over 2. Now here's how I want you to write your answers. Remember, we kind of had answers that looked similar to this when we were doing complete the square. We had some answers that were close to this. Split it apart. Do 4 over 2 plus or minus 2 radical 13 over 2, and then try to simplify each fraction separate. And we're just going to leave the plus or minus in the middle. Okay? Because I can't add the 4 and the 2 radical 13 together because the radical 13 messes that up. So 4 over 2 turns into 2. And then what happens with the 2 out front and the 2 in the bottom? They cancel out. So we just get 2 plus or minus the square root of 13 as the solutions for that one. Again, that one could have been solved with complete the square, but I'll be honest with you, you don't usually choose complete the square because quadratic formula and complete the square have about the same amount of work without having all of the extra squaring that you have to do in complete the square and factoring that's happening. So you're probably thinking, well, why in the world did we spend a day learning complete the square? When we go next week to the graphing, we need to be able to turn equations into a certain form, and you got to be able to complete the square to get it into that form. So the skill is important to do that. Number 7. -3x squared plus 8x minus 7 is equal to 0. Okay. So we're looking at this one. We look at it and see, oh, it's in the right order. It's equal to 0. So I gotta solve that thing. -3 in the front times a -7 in the back is +21, and it's got to add to be 8. The only things that multiply to be 21 are 21 and 1 and 7 and 3, none of which will add to be 8, right? So I know factoring's out on this one. So I know quadratic formula or complete the square are my only options. I'm doing quadratic formula. Complete the square, you usually don't choose that one unless you're forced to do that, which you got to know how to do it. So I'm got A, B, and C, so I'm doing a discriminant. So 8 squared minus 4 times -3 times -7. 64 minus 12 times 7 would be -84. So 64 minus 84 would be -20. So my discriminant is a -20. So that means I'm going to have 2 complex solutions. I got a negative for my discriminant, so I know it's complex solutions. Okay. And I'm going to go do my quadratic formula. X equals negative b plus or minus radical b squared minus 4ac divided by 2a. So I need to break down the negative 20. So 20 would be 10 and 2, 5 and 2. There's a pair of 2's. So that's going to be x equals negative 8 plus or minus 2. What else comes out with that 2? An I because it was negative, and the 5 is left over. On the bottom, we got a negative 6. 2 times negative 3. Negative 6. So anytime we got a negative under the square root, you know an I is coming out for sure. May not be anything else comes out, but an I is coming out for sure. And then we're going to do the same thing as we did on the previous problem. We're going to split that into 2 fractions and then simplify each fraction individually, because that's the easiest way to do that. So that's going to be negative 8 over negative 6 plus or minus 2i square root of 5 over negative 6. So negative 8 over negative 6 reduces to be positive 4 over 3. 2 and negative 6 both divisible by 2, so that's going to be plus or minus I radical 5 over 3. Where did the negative go? Into that plus or minus. Yeah, that plus or minus, if it's the positive 2I radical 5 divided by negative 6, that turns back into the minus. If it were the negative 2I radical 5 over negative 6, the negatives cancel out, and that turns back into the plus. So that plus or minus takes care of the negative and positive for us there. So it really works out nice. So these are our solutions here. 4 over 3 plus I radical 5 over 3, and 4 over 3 minus I radical 5 over 3. So a complex solution there. Let's do one more with just quadratic formula. 5x squared plus 9 is equal to 4x plus 5. And then we'll finish up with just kind of some throwing some quadratics up there, and let's try to talk about what's the best way to solve. Okay, so this one, let's use quadratic formula to solve. So what do we do first? That's right. Good answer, guys. Minus 4x and minus 5. So 5x squared minus 4x plus 4 is equal to 0. Right? Do that right? Okay. Now, if I think factoring 4 times 5 is 20, multiplied by 20 had to be negative 4. There's nothing that does that. So quadratic formula is really your only option here. So I'm going to do the discriminant. So negative 4 squared minus 4 times 5 times 4. So it's going to be 16 minus 80, which is negative 64, which is a negative number, but it's a square number. But still, that tells us that we're going to have 2 complex solutions. Not necessarily rational here, because the complex part trumps rational, right? It's a bigger picture than rational is. So 2 complex solutions on this one. So we're just going to go and do the quadratic formula. Negative b plus or minus the square root of negative 64 over 2 times 5. So that's going to be 4 plus or minus. What's the square root of negative 64? 8i. Good job, guys. And then 2 times 5 is 10. And then we're just going to split it up. 4 over 10 plus or minus 8i over 10. And simplify each fraction. It'll be 2/5 plus or minus 4/5. And you can either put the I up in the top with the 4, or you'll see it commonly written out to the side. Either way is fine. I don't care. I'm not going to be picky there. Your calculator, if you were to do complex numbers, when we talk about adding and subtracting complex numbers with the calculator, it'll put the I to the side of it. So that's kind of why I write it that way. But technically, it doesn't matter. So there's our solution to that particular problem. Okay. Not bad. Pretty easy. Okay. All right. Let's look at some problems, and we're going to choose a method. So we're going to talk about what's the best and most efficient method to do this, these particular problems. So I'm going to start with this one. 10x squared plus 2 is equal to 282. When I look at that problem, before I do anything as far as moving stuff, I need to look at the problem and see what's there and what's not there. What's there? A's and C's, but no D's. No plain X problem or part of the problem. No plain X. If there's no plain X, then what's the easiest way to solve? Factoring might be a good way if we could do differences of squares. This one won't do that. Differences of squares and what other method will get the same solutions? What did we do right before Fallbrook? That was right after Fallbrook. Go back one step before that. Square roots. Because it only has an x squared in there, that's the only variable. Anytime you see plain old x squared in there, no regular x, square roots is going to be your quickest way to solve. Okay? So anytime you see a problem and you see, hey, it doesn't have a regular x in it, then either factoring with differences of squares or square roots. The problem with doing differences of squares is the fact that not every problem will be a difference of squares. But every problem we can take the square root of if it just has x squared. So I'm going to take this one and solve it by square roots. So subtract 2 and be 10x squared is equal to 280. And then divide by 10, right? X squared is 28. And then take the square root of both sides. Plus or minus on the number side. There's x by itself. I need to break down the 28. 14 and 2 or 7 and 4, it doesn't matter. There's a pair of 2's, so plus or minus 2 radical 7. Could you have done that one with quadratic formula and got the same answers? Yes. Quadratic formula works every single time, but it may not be the quickest way to get there. Just like going up 45 north to Jackson will get you there, but it may not, but depending on where you're starting at, may not be the most efficient way to get there. Because if you're starting from Savannah to go to Jackson, going up 45 north may not be the most efficient way. It'll be better for you to take Highway 69 into 22 and then go up that way. Cut across at 100 to get to Henderson. There's a lot of different ways to get there, but where you start at matters. Okay, let's look at this one, number 10. X squared minus 7 equals 6x. Can this one be done with square roots? No, why not? What's the reason it cannot be? It's got the plain x. So if it has the plain x, you always want to get it equal to 0 first. If you've got the plain x, you want to get it equal to 0 first, because that's going to open up different options for you. You get it equal to 0, what are the two options it opens up for you? Factoring or what we just did, the quadratic formula. Those two options both have to be equal to 0 to even start them. So getting it equal to 0, if it has the plain x in it, is the best starting place you can be. And then I'm just getting it in order, the right order. And then I look at it and say, the first thing I always check, and this is kind of my checklist as I go along, is I look at it and I say, can it be factored quickly? X method for this one, so it's got to multiply to be what? -7 and add to be -6. Can I come up with the numbers that do that pretty quick? Yeah, there's only one option to be multiplied to be 7. It's 7 times 1. We just got to get the sign right. So if I do the X method, it'd be -7 and +1, right? So I can get those numbers real quick. What also makes this problem really quick about solving by factoring? I can take the shortcut because it doesn't have anything in front of x squared. Okay? So I'd have x minus 7, x plus 1 as my factors. So I get there pretty quick. That's a lot quicker than quadratic formula would have been, because I didn't have to do all the stuff under the square root and all that stuff. And then I set those equal to 0 and get 7 and negative 1 as my solutions. Could I have got those solutions with quadratic formula? Absolutely, you could have. You would have got the same answers if you did it correctly, but it would have taken more work. If I try to do X method and I don't get those numbers within the first 2 tries, I'm jumping to quadratic formula. If I have trouble getting the numbers on the X value, on the X method, then I jump to quadratic formula, because it may not even factor at all. But I know quadratic formula will work. Okay, let's look at one more that is kind of, well, a little bit on the strange side maybe. X squared plus 12x plus 3 is equal to 7. Number 11. I'm just going to look at 2 more. What do we see this one has? Plain X in it. So that means we need to get it to equal to what first? 0. Before I can decide what method I'm using, I'm going to get it equal to 0. So x squared plus 12x minus 4 is equal to 0, right? And now my first stop on the train track here is to think about factoring. Is there any way that I can multiply to be 4 and add to be 12? No. That's an easy thing to look at and see. If that number is kind of small and the middle number is kind of big, it's not very likely that they're going to factor. So what's the method that I want to use here? Quadratic formula, or complete the square. If you want to complete the square on this one, you could. It'd be nice. It'd work. But I'm going to do quadratic formula. So it'd be 12 squared minus 4 times 1 times negative 4. 144 plus 16 is 160. Is that a square number? 160 is a square number? Square root of 160 is definitely not a square number. So that tells us that this has 2 real solutions. That's what we know. It means it's going to have a square root left in the answer. That's what that means. Okay? And then we're just going to set it up. X equals negative b plus or minus equals b squared minus 4ac divided by 2a. So that means I need to work to simplify the square root of 160. That's 16 times 10. 4 and 4. Hey, there's a pair of 4s. 2 and 5. It doesn't. So it's 4 radical 10 over 2. What do I do from there? Split it up. Negative 12 over 2 plus or minus 4 radical 10 over 2. That'd be negative 6 plus or minus 2 radical 10. Easy to do, right? Again, factoring is going to be my first look, because I've probably done more of that than I've done anything else in Algebra 1 and Algebra 2 together. Quadratic formula, I probably haven't done as much. Let's look at one more. Last one. 4x squared minus 39 is equal to 10. What method looks like it'd be the best way to go here? Difference of squares or square roots. Either way, both are almost the exact same amount of work. If we do square roots, what do I do first? Add the 39. Get 4x squared is equal to 49. Now what? Divide by 4. So x squared, and then 49 is not divisible by 4, so that's going to be 49 over 4 and then I take the square root of both sides, right? 7 plus or minus 7 over 2. Perfectly fine. If you did differences of squares, which is not wrong, what's the difference in how you do it? Subtract 10 instead of moving the 39. And that's going to be 4x squared minus 49. And we know the factors for that are what? Yeah. And we set each of those equal to 0. And there we get negative 7 over 2. And positive 7 over 2. Same two answers, two different methods of getting there. If I'd have done quadratic formula, would I got the same two answers? If I did it right, yeah. All of those methods would work there, okay? So as you're working your way through this stuff, the first homework that I'm going to give you, the homework 7, is just quadratic formula. That's what I want you to do the whole time on homework 7. It says it at the top, quadratic formula. That's what I want you to do on that one. Okay, so I'm going to give you that one first. All right, so this one is quadratic formula only. That's the only method I want you using on homework 7. It's quadratic formula. So I should see a discriminant and then the quadratic formula worked out on 1 through 12 on that one. Okay, so that's what I'm looking for on homework 7. Homework 8